Today we will talk about a long method. And in the lessons I already told you that we have some rules what method can be long, how much lines of code we can have in the one long method. And usually we named long method not only long methods with more than 100 lines, for example. Sometimes the method can be shorter than 100 lines, but if this method is very hard to understand, we can use the solutions to change this situation for long methods. And when a method is very long, it becomes hard to understand because we don't know what is important in this method and what is not. It takes more time to read and think about it to understand it. But if we choose a good name for method, we don't need to read all the code inside this method, and the name tells us what the method does, and it can save our time. Also, if we want to write a comment to explain part of the code, maybe sometimes it's better to move that part into new method and give it a clear name, and it will be easier to read. Sometimes the total number of lines in the method will grow, but if it's easier to understand it, I think that it's okay. We can save this long method without any separation. The first example of the code, it's not long, I understand. It's just a little example when we have some code which it's hard to understand. And we can change this situation, we can make it more understandable with special refactoring method, which we call compose method. It means that we take a method and separate it into small and clear steps. Each step should do one thing, not one command, not one line of code, just one thing. And each step should be at the same level of detail, not too low, not too high. Also, the names of these steps should explain what they do, and in this way, method looks like a list of easy instructions. It's easier to read, easier to test, and easier to change if we want to do it. So in this slide and in this, we have the same code, but here we replace the part of our method to little functions with clear names, and I think it's easier to understand what this method does. This makes the code look more organized, like a list of steps. Each step is simple and clear, but sometimes if we use compose method as a way of refactoring, we will create too many small methods. This can make debugging harder because the logic is now split across many places and we need to jump through these places when we debug this code. So this method of refactoring is helpful, but we need to use it with a balance. Always, when you're refactoring something, always remember about the balance. The next method of refactoring, in 99% of cases, if you want to change something with a long method, you can just separate this method into some parts, like this animal in the image. And we already did it in the previous practice, in the previous lesson, and you did it in a practice lesson in university with Vladislav. So sometimes when we try to separate our method into some little parts, we can have a problem. And the first problem, it's a lot of parameters. Here in this slide I have an example. in the left part of the slide, I have example with get some information about the user, and I create a new method save user, and I need to send three parameters into this method, but I don't want to do it. I already told you that when we have a lot of parameters inside our method, it's not so good because we need to remember these parameters in our brain, but I can't remember more than seven variables. Here I have three parameters. It means that in the method I can create no more than four local variables. I think sometimes it's not enough for me. That's why I want to decrease the number of parameters of my method. And I can use special method of refactoring, which we call replace stamp with query. It's from literature, it's not my idea. Uh, Maybe it's a strange method of refactoring, and I hope you understand why. So here we can no, sometimes in our code we use temporary variable to save some result. Like here we create variable base price and use it, but I want to remove this variable. Instead, I can use a method, and like in this slide. Oh, animation. uh, Maybe it's a strange method of refactoring when we replace our local variable with running of method. And inside this method, I will just count the base price. I will call quantity multiple item price. So in the second example, I don't need the local variable. I decrease the number of local variables, but I use special method for it. And every student usually thinks that it's a bad idea. Maybe you can tell me why it's a strange method of refactoring.
Maybe because we are increasing the complexity and we are jumping from one place to another just for one line of code.
Maybe, but here we have a simpler reason why it's strange.
Because instead of well, the double's been moved below. This it's returning a value. Um, hmm. it turned like basically just base price that was a variable into a function.
Yeah, we replace the variable with a function. And in every year of this discipline, students tell me that it's strange. Why?
So I mean, just use the variable. I don't see why you need to.
Uh, Guys, think very simple. When we replace the local variable with method, we need to run this method in every time when we need this value. It means that we will count the base price in every time. In the first example, we do it just once, and in the second, we will run it one, two, three times. It's not so optimal, I think. Uh, this example can show us the difference between refactoring and optimization of our code. Here we make our code bad if we think about optimization. It will work slowly. But if we think about refactoring, we remove the local variable, and sometimes it can make our code more readable because we don't need to remember about this local variable.
So instead of calling the variable over and over, yeah, you just make a function that does it. That makes it more streamlined.
Yeah. It's a strange way of refactoring. But in literature we have it, and sometimes we need it if we already have a lot of local variables inside our code. Uh, Sometimes we can use it.
So just a quick question: if this does make the code a bit slower, less optimized, but will we be given extra points when we're doing the project for
Yes.
optimization, or is it just about refactoring?
In the project, I will count the refactoring, not optimization.
Okay, thank you.
Okay, yeah, it's a strange type of refactoring, I think. But when we use it, we can make the first example of code to second. We just remove all parameters and use little methods to get some information without sending any parameters. Then, when we work with parameters, we usually can find the case when our parameters connected semantically. Like in this class customer, we have several methods with the same groups of parameters, like start and end with type of date. I think here we can make some refactoring. Maybe you have an idea how we can work with it, how we can change this code to decrease the number of parameters.
Probably use data class.
Yeah, you are absolutely right. And this method of refactoring we named introduce parameter object. If we have some groups of parameters which we can find in several methods of our code, we can replace it with data class, or for another languages with just class, and move all parameters into this new class. Uh, this makes the method easier to read and call. If this new object has some useful behavior, we can move that behavior into a new class. For example, for date of start and date of end, we can add the behavior some validation when we check that our start date is before the end date. Usually, if we just use start and end dates like parameters, we can validate them, but we need to make this function in some strange place, I think. If we will create the date range class, we can add this validation logic inside this class, and it will be very good. Uh, if the object only stores data and has no logic, we can create a bad code example. We call it anemic domain model. And in Kotlin, in Android, or in C Sharp, it's just a data class. And it's very interesting that in languages like C Sharp or Kotlin, we have special type to create the object without any behavior. But in literature, in theory of refactoring, we count that it's a bad code. But we use it. Sorry, it's my dog. Here we can just replace the group of parameters with a new object. Use this technique when grouping makes sense, and when you can add behavior into this code. Like in this example. But please remember that when we create new object for this group of parameters, we will create new dependency. Sometimes new dependency is not so good, and we always try to decrease the number of dependencies in our system. The next case, when we try to separate our long method into some parts, but logic is too complex, and we have such complex relationships inside this method, then we can't separate it because we have a lot of variables. We maybe should return group of results in some method, so it's very hard to separate it. And we can use in this case the refactoring method, which we call replace method with method object. It's very interesting, I think, because it's very unusual for me. In this case, when we have a very hard, very complex method and we need to separate it, we can create special class for this method, move our code with this method into this class, and make local variables the fields of new class. When we create the fields, it means that every we can use every field, get information or change information inside it in every method of our class. And in this situation, we don't need to send the parameters to return something. We can just separate our big method into some steps. And we solve our problem with separation. We move the method into a new class, and the local variables become fields of this class, and we can do it. So in this diagram, I have not in this diagram. In the left part of the slide, I have example of code. Here I have a class order with a method price. And inside this method, I have some local variables, and it's very hard to separate this method into parts. That's why I create new class price calculator. These local variables will be fields of this class, like in my diagram, and I can just run the method compute, and inside this method I will run some little steps of my computation. And I will have not any problems with the local variables, because all local variables are fields of this class, and I have access to them in every place of my code. Putting a long method into its own class helps stop it from growing too much. This new class gives us space to split the method into smaller parts, and we don't need to pull all of this small method into the original class. We can hide them into in our new class. So it means the original class stays clean. But sometimes we can have a disadvantage because we create one more class. It makes the whole program a bit more complex. So we use this technique when the method is very complex and when it's hard to break it into parts inside the same class. When we have the long method, we need to decide how we should separate it into parts. And in literature, we have a little recommendation that it's better to start from conditional operators and loops. Just move first of all conditionals and loops into new little methods. And little example how we can work with our conditions. Here I have an example of code, and please look at the condition in the first line of code. Usually all students tell me that we need some little time 1 second or 2 seconds to understand that inside this condition we have a very simple rule that the date is not summer. But we need this time. We need to think. We don't want to think. We are too lazy. That's why sometimes we need to make our code more readable. Of course, here I use an example which is not so complex to understand. It's just an example. And sometimes we have such complex condition or complex logic inside the body of my condition, that we need to replace it with new method with understandable naming. And this code we can move into this one when I replace the condition with new method, and I think that understand not summer more easier than this condition with or condition, and we replace the then part and else part with a new method with understandable naming. This type of refactoring we call decompose condition, and we can use it not only when we try to solve problems with long method, but in another types of bad code, which I will show you in the next lesson. Again, it's a description of decompose condition. It means that we just move our code from condition to new method, from then part to new method, and from else part to new method. But don't forget about good naming, because if you will move your code to new methods and not use good naming, I think you will decrease the quality of your code. The next example. Why I have this animation? I don't remember that I created it. The next case, it's more complex, and it will use the patterns. That's why you will need to repeat the design patterns or OOP patterns. Here I have a little example when we have long method, and this method is long because it contains the if condition with some logic which determine what we need to do with some condition. Here it calls conditional dispatcher, and we just check some value, for example action name, and we depends from this action name, and we should do some steps. We can replace this conditional dispatcher with special pattern command. I hope that you remember what is this pattern. If you don't remember, please repeat it, because every developer should know patterns like command, strategy, singleton, and another, and you already have the discipline about patterns. So we can replace our big conditional logic with this pattern. This is slide about what is this pattern. It allows us to replace some actions with objects of actions. We just separate our code into some steps, and every step will be inside its own class, inside little command. In books about patterns we have such diagram, but I don't like it because it's very hard to understand what it means. But if tell about our example, we have the complex and very long code with a lot of if conditions, and we can remove it with this hierarchy of objects. When we create the special class for every part of our if condition, for this one, for this one, for every else if part inside our condition, and when we call this long method, we just use such type of handler which we need to do and execute it. So we replace very long condition code with one line of code when we just execute something, and all of these lines of code will be hidden inside these classes, inside every handler. This pattern help us run different behaviors in the same way. Instead of using many if or switch statements, we create one command for each action, one class of command for each action. This makes it easy to change behavior at runtime because we can replace one command to another command uh, depending on what kind of request we receive. We just run the right command, the method of execute inside this command. It's also simple to implement in most cases. I think a command pattern it's not so hard for understanding. But if we have a few conditions, this pattern can actually make the project more complex. Uh, because we will create many small classes and sometimes it's too much. So use this refactoring when the logic is big or needs some flexibility, but don't use it for small code with just one or two simple conditions because it's over engineering, I think. The next example, when we have the long method, because inside it we have a condition again, but this condition has some specialties, some special behavior. Here I have some hierarchy of nodes, like in XML, for example, and I want to use every type of this hierarchy to get some information from it. For example, I want to parse my XML and create the string from it. And that's why I need to, I think that you sometimes all of us create such code when we just check the type of some object and do something. Like here, I just check that I have the instance of string node and make some lines of code. Then if it's instance of link tag, I do something and moreover. It's not so good code, it's very long, it's hard to support it, and I want to refactor it. In this situation, when we need to go through a lot of objects with different types, but with one interface, here I have one interface node, I can use special pattern, and we call it visitor. Maybe you don't remember this pattern because I think it's the most uh, complex pattern of object-oriented programming, but it's very flexible, it's great, I like it, and I recommend you to read about it and to understand how we can use it. Visitor pattern allows us to go through the objects and call something inside it objects. And in our situation, it's bad code, we can replace this condition with this hierarchy of object. I create, not I, but the author of book in which I found this example, create the interface visitor, and inside this interface we have special method for every type of our nodes. We create the text extractor, it's a concrete visitor with all of these methods, and we replace our very complex condition with little code with just while loop with one line of code. Inside this while loop, I will go through the list of my objects, and for every object, for every node, I will run the method accept. Every tag in my hierarchy has own method accept, and inside this method the object, for example, link tag, will call the method of my text extractor. Here it will be, if I use link tag, it will be visit link tag. And inside this method, I will hide the logic about what information I need to get from my link tag. It's hard to understand. It's maybe very complex, uh, but let me try to explain again with this sequence diagram. My visitor call method accept inside every node. Then inside this accept method of my node, I will run the method visit string node or visit link tag. It depends from what type of node I want to use. And inside this method visit string node, I will get all information what I need from nodes and put this information into my string. If I want to get all information from XML, for example, and move it into string variable to print, for example, or send to some server if I need it. It's a visitor pattern. It's very complex, but it's better to understand it because it's very powerful. For example, I can use the hierarchy of visitors and I will write the method of visit every object inside my children visitors. It means that I can change the behavior of visitor, I can change the information or some actions what I can do with this hierarchy of nodes. Uh, Storage visitor can use uh, some information to store it. Catalog visitor can use another information of all of this hierarchy of object. Uh, it's very flexible. We can use it in some interesting places. For example, one of my students use visitor when he needs to create very complex form inside mobile application and in the when the user will add information inside this form, we need to get all of this information. And we can use this pattern visitor. Visitor will ask every part of our complex form to get information what we need to send to the server, for example. This helps us separate logic from object classes. Uh, it's good when we need to collect data or do operations on many objects and sometimes we can visit classes of different hierarchies, but there are some problems too, as usual. If we could use a common interface, visitor might be too much. For each new class, we must add a new method to accept the visitor, and sometimes visitor can break encapsulation because visitor knows a lot about every object. It's not so beautiful. It needs to look inside the object's data, and sometimes it's not very good. This pattern is very powerful, but use it when the structure is complex and simple solutions don't work well because it's a complex pattern. Sometimes your teammates don't know about this pattern and it can be problem because you can add the visitor and your teammates will not understand this code and tell you that you make your code uh, worse and harder to understand. So it's not refactoring, maybe sometimes. But I hope that all of your teammates will know about this pattern. The next example, again, it's a very long condition, and again with some special parts. Here I have a condition, and in some cases I use one variant of algorithm. In another cases, I use another variant of algorithm. So from some conditions, we decide what variant of algorithm we need to use. It's not different actions inside our condition. It's just some ways of one algorithm, some ways how to count something or something else. And in this situation, we can use we cannot use this terrible animation. uh, we can use special pattern strategy. I hope that you remember it because I don't know why, but in every year foreign students know everything about strategy. Nothing about another patterns, but knows about strategy. This slide, I hope, help you to remember what is it. Strategy, it's a pattern which allows us to create special class for every variant of one algorithm. For example, bubble sort or another merge sort or something else. We just use different variants of one algorithm and create a special class for every variant of this algorithm. And in our case, we will replace this not so good code, long method, with hierarchy of classes, and we just move our code to special classes and replace long method with one line of code in which we just call such variant of algorithm what we need. We just create this strategy and run the method capital to get result. And that's all. I think it's a very good variant of refactoring. It also gives us flexibility. We can change the algorithm at runtime if we need it, just by using a different strategy object. But again, there are also disadvantages. It can make the project more complex, especially if simple if condition can be enough. And sometimes the algorithm needs data. That's why we need to pass some parameters inside strategies, and sometimes it can be hard to pass them in a clean way. So strategy, it's a great pattern, but we should use it when the logic is complex and when we really need to switch algorithm. And that's all for today, and that's all for long method. Here I have the list of refactoring methods. Here we use here we don't use any patterns. We just extract method, just separate something. And here we use patterns like command, visitor, or strategy. Uh, you can use this information when you create the first laboratory project, because it's better to determine what not first, sorry, in third laboratory project, because you need to determine which way of refactoring you will use. That's all for today.